Hi, I'm planning a trip to Yosemite National Park and I am so lost. These maps just aren't telling me what I need to know. What attractions are near my camp? What's the closest place I can hike to? Redis's geospatial indexes can help, so let's find our way together. Redis geospatial indexes store named points in their associated latitude and longitude coordinates. They are fast, always in memory, and can be updated instantly, which makes them ideal for reflecting the real-time location of users, vehicles, and really anything that moves. Once we add locations to a geospatial index, we can answer a number of important location-based questions. Things like, what are the 5 nearest ranger stations to my current location? And how far is it from here to the base of Yosemite Falls? Today we're going to cover the basics of Redis geospatial indexes through the development of an app for Yosemite National Park. We'll learn how to create a geospatial index in Redis. We'll then list the closest attractions to a user's location. Lastly, we'll expand upon that list with optional commands that return information we can use in our app. To add an item to our geospatial index, we'll need a key, which is the name of the index, plus a latitude, a longitude, and a unique name or ID for this specific location. We'll name our index Yosemite:attractions. Here I have the coordinates for El Capitan, a famous 3,000-foot wall of granite in Yosemite. We'll store specific information about El Capitan in another part of our database as a Redis hash, so we'll just reference it by ID in the index. Let's say it's 14. To add this location to our index, I'll use the geoadd command. I'll enter the command geoadd Yosemite:attractions, then El Capitan's location coordinates, and then its ID, 14. GeoAdd can add multiple locations at once, so I'll run the command again to add Half Dome, Mono Lake, Vernal Falls, and Bridal Veil Falls as well. If we know a user's current coordinates, we can find attractions within a given radius of that location. The command for this is georadius. Let's say I'm at the visitor center in Yosemite and I want to know what attractions are within 4 kilometers of my location. I'll enter the command georadius Yosemite:attractions, our current coordinates, and 4 km for the radius in units. This returns the list of attraction IDs 25 and 32, which correspond to Mirror Lake and Half Dome. We can take georadius even further with just a few optional arguments. To return the distances from the provided location to our attractions, add the WithDist argument. This adds the computed distances from our specified center for each geospatial item. To plot our return list's locations on a map, use the WithCoords option. This provides the longitude and latitude along with the key. By default, georadius returns coordinates in an unsorted order. If you want to order the location from nearest to farthest, use the ascending option. This is useful if you want to list the closest geospatial items first within the radius as a list for the user. Conversely, use the descending option to provide a list starting from the farthest distance to the nearest. Lastly, to limit the number of geospatial items returned in a georadius command, use the count option. This will greatly reduce bandwidth when you know you only need the first few results from a georadius query that's likely to return thousands of locations. Okay, let's review. We just learned how to add locations to a geospatial index of geoadd. We also learned how to find all locations within a given radius using georadius. Lastly, we used optional georadius arguments to include useful information and modify the counting and sorting methods. To learn more about Redis geospatial indexes, check out our free online course, Introduction to Redis Data Structures. It's part of Redis University, our online learning platform for all things Redis. Thanks for joining me on this hike into the vast forest of Redis geospatial indexes. Happy learning and hope to see you again soon. Now how do I fold this thing?